Hello everybody and welcome to this lesson. Today we're gonna go over some past paper questions for the syllabus 0580, which is the Cambridge International Syllabus for Mathematics, and we're gonna do mensuration today. So as usual, let's start with the easy ones and work our way up. Calculate the perimeter. So as you recall, the perimeter is just, imagine you're an ant and you start in one corner or at one point on the edge of a shape and you walk all the way along the edge of this shape. How far will you have walked by the time you get back? And it's pretty easy because all you have to do is add up all these distances. So the thing is that we don't have this distance and this distance. So this is the most straightforward thing to do, is first we calculate this distance, which is equal to 0.9 minus 0.4 is equal to 0.5 meters. And then we have this distance minus this distance is also equal to, let's do it in the calculator, 1.2 minus 0.7 is equal to 0.5 is 0.5 meters. So when I want to calculate the perimeter, all we have to do is do 0.5 plus 0.5 plus 0.4 plus 1.2 plus 0.9 plus 0.7. We just plug it in the calculator over here and we get 4.2 meters. Now, what about calculating the area? The area is also pretty easy, right? Because it just consists of this shape consists of two rectangles. We can cut it up like this, in which case we have area 1 and area 2. And once we calculate the area of each, we just add them up after that. So we get the area 1, 0.5 multiplied by 0.4 equals 0.2. Let's be concise and add meters squared over there. And area 2 is equal to 0.7 multiplied by 0.9. So finally, area 1 plus area 2 is equal to 0.63 meters squared. And here we 0.83. It's equal to 0.63 plus 0.2. 0.83 meters squared. And let's move on to the next question. Leia is making a path in her garden using gravel. The diagram shows the path. A bag of gravel covers an area of 0.5 meters squared. We want to know the number of bags, and we see that it's a 3-point question. So what we really need to do is, we know that one bag covers this area, so we need to know the total area and divide it by this to get the number of bags. So the total of area is again two rectangles combined. This area and this area. This one is easy. 0.8 multiplied by 3. This one is also easy, but there's a little bit of a trick. We have to be extra careful that we take this distance and not this distance. This distance is 6 meters. So this distance is 6 meters minus 0.8. Right? Because if we did it over here, used 6 meters, we'd be counting this part twice. We don't want to count that part twice. So let's see. A2 is equal to 6 minus 0.8 multiplied by this height, which means that A1 plus A2 is equal to, let's do it. Let's do the whole calculation over here in one time. 0.8 multiplied by 3 plus, and now open brackets, 6 minus 0.8 close brackets multiplied by 0.8 gets us 6.56 meters squared. So we need to buy 6.56 divided by 0.5. That's the number of bags we need to buy. $13.12. But can we in the shop usually buy 0.12 bags? No, we need to buy the whole bag. If we need part of a bag, we need to buy the whole bag. So we need to round it up in this case. So we end up with 14 bags. You know, you can't buy half a bag usually in the shop. Next question. Calculate the total surface area of this cuboid. So to calculate the surface area of a cuboid, we just have to calculate the area of each face of the cuboid and then add them up. So we're going to take the front face, and the front face is exactly the same as the back face. So we're going to count it twice. So the front face is 7 multiplied by 5. Remember, this height is equal to this height because it's a cuboid. So we have 7 times 5 equals 7 times 5 equals 35. I could have done that by head, in my head. Centimeters squared. The side face is equal to 4 times 5, which is equal to 20 centimeters squared. While the top face is equal to 7 multiplied by 4, is equal to 28 centimeters squared. If you can't do this mental arithmetic, that's fine. You just do it in the calculator. Okay, so remember I said I have to count each of them twice. So the front is the same as the back, so I count it twice. The side is the same as the other side, so I count it twice. And the top is the same as the bottom, so I count it twice. So we're going to end up with 2 times 35 plus 2 times 20 plus 2 times 28. Two times 35 plus 2 times 20 plus 2 times 28 is equal to 166. Let's write it down here. Okay, a cuboid has a square base. The volume of the cuboid is 867 centimeters cubed and its height is 12. So we know that in a cuboid, if it has a square base, the width and the height is going to be the same, right? The width and the length is going to be the same. Excuse me. So the length of one side of the square base, so let's just write an expression for the volume. Volume is equal to width times length times height in the case of a cuboid, right? In this case, we know that the length is the same as the width. So we're going to rewrite this as length times height, which we can rewrite again as length squared times height. Okay, then we'll just fill in some numbers. 867 is equal to length squared, because we don't know the length, we want to know length, times the height is 12. Now we want to divide both sides by 12. Remember with algebra, what I do to the left hand side, I also have to do to the right hand side. If I divide both sides by 12, then the 12 in this side is going to disappear. So we end up with L squared is equal to 867 divided by 12. 72.25. And again, I want to get rid of the square root, so I have to do the opposite of the, I want to get rid of the square, so I want to do the opposite. So I square root it. And what I do on the left-hand side of the equation, I also have to do to the right-hand side of the equation. So I end up with the square root of 72.75. Is equal to 8.5. Okay, very good. Moving on. We're now doing the medium questions. The diagram shows a semicircle with diameter R9. Calculate the total perimeter of the semicircle. So we want to calculate this distance, which we know is 9, plus this arc distance. And this arc distance will be, because it's a semicircle, exactly half of the total circular distance. Or we could take this angle, which we know is 180 degrees, because it's a semicircle, and divide it by 360. In this case, we also end up with exactly a half. So what's the circumference of a circle again? C is equal to pi multiplied by d. And in this case, the perimeter is going to be equal to half of C plus D. So half of C counts for this part, plus D counts for this part. That's the perimeter, the total perimeter. Okay, let's plug in some numbers. C is equal to 3.142. Remember, on the exam, you have to follow the instructions in the beginning. It says use 3.142 for pi, or your value on which you found on the calculator. 3.142 multiplied by 9, which is equal to, I'm going to use the value in my calculator, which is this 3.141592654 multiplied by 9 equals 28.2743. Pre 882. I'm gonna write it with a lot of decimal places so that when a rounding error occurs, I want it to occur much later in the question. Yeah? So there's gonna be a very small rounding error, but a very small rounding error doesn't matter too much for me, because sooner or later I'm gonna write it to 3 significant figures. Okay, so now we have P is equal to half C plus D. What is half of this? I can just keep it in my calculator for now. Divided by 2 equals 14.37166. 14.3716691 plus 9 equals 23.37. I think that's enough decimal places. 23.37. Oh, excuse me, I made a mistake. Can you spot where I made a mistake? So you see, teachers too make mistakes. I left out this one. It's very important to be well rested and very careful when you're taking the exam to avoid exactly this kind of sloppy mistake. Okay. A cone has a radius of 4.5 centimeters and a height of 10.4 centimeters. Calculate in terms of pi the volume of the cone. And they're nice enough to give us the formula for the volume of pi, so it's a pretty easy question, right? All we have to do is be careful that we read the question carefully, because it says in terms of pi. So we have to leave pi as a symbol in the equation. So a cone has a radius of 4.5 and a height of 10.3. You just do V equals 1/3 pi r 4.5 squared times height 10.4, and you just plug it in the calculator. So we end up doing 4.5 multiplied by 4.5 plus, excuse me, multiplied by 10.4, and then multiplied by 1/3, which is the same as dividing by 3. 70.2. Don't forget that I did not plug in a value for pi yet. .2 pi. A solid cylinder has a radius of 3 and a height of 4.5. We want the surface area of the cylinder, but they don't give us the equation. So that's okay, you can just memorize the equation or the formula. But what if you forget? There's an easy way to remember. A cylinder, you can just unwrap it. And when you unwrap it, you get the area at the top and the area at the bottom. And these two are equal. So we got the top area of the cylinder and the bottom area of the cylinder. If we unwrap the sides of the cylinder, we end up with a height, which we know is 4.5, and this distance is equal to the circumference of the circle, right? So in the end we have 2 times A, because we're just summing up the areas of the surface of the cylinder, plus C times H. So that's an easy way to remember in case you forget. 2 times pi r squared. The area is pi r squared. The circumference is pi times the diameter, and the radius is 2 times the diameter, so we end up with 2 pi r, and the height we know. So then we just fill it in. Let's do the first one first. Delete pi multiplied by 2 multiplied by 3 multiplied by 3. 5, 6, 5, 4, 8. 6, 7 plus 2 times pi times 3 times 4.5. 84. Okay, let's add the two numbers together. Equals 141.37167. Close enough. So I rounded this one quite late, and I left quite a lot of figures behind the decimal place to minimize the rounding error, and here too to minimize the rounding error. But now that I've got the final answer, I'm going to leave it to 2 points behind the decimal place. Normally the exam would tell you exactly how many decimal places you need to leave at the front page, but I didn't do that in this case. So let's just use our common sense, and we just leave 2 decimal places. Should be fine, right? Okay, next question. The diagram shows a right-angled triangular prism. Work out the volume of a prism. So you remember that every prism, no matter how weird the cross-sectional area is, always has the same, so long as the cross-sectional area remains exactly constant, it always has the same formula for the volume, which is the area multiplied by the length. in this case, what is the area, the cross-sectional area, and what is the length? So this is the cross-sectional area, which will be given by 7 centimeters base plus 4 centimeters height. And this will be the length, 12 centimeters. So to calculate the area of a triangle, as we all know, is half base height equals basically 7 times 2, because this cancels, and then we have 14 centimeters squared. Area, and that means the volume will be 14 multiplied by 12 equals 168. Okay, moving on to the next question. We've got question 9. A square has a perimeter of 12x. Find an expression in terms of x for the area of the square. Give your answer in its simplest form. Okay, that's an interesting question. We know the perimeter, and we want an expression in terms of x for the area. So the area, as we know, is the length times the length. And the perimeter is equal to 4 times the length, because it's a square, right? So we know that 12x is equal to 4L. Let's rearrange this. I want to simplify L. I want to simplify this, so I'm going to divide both sides by 4. Remember, 4 multiplied by L. What's the opposite of multiplying? Dividing. So I'm going to do the opposite to it in order to make the 4 go away. That cancels. 4 divided by 4 is 1, so we end up with 1 multiplied by L. 12 divided by 4 is 3. So we end up with L equals 3x. And now we just fill our expression for L in over here. A is equal to 3x multiplied by 3x, which is equal to 3 times 3 is 9. X times x is x squared. 9x squared. 9x squared. Very good. Okay, now we're moving on to the difficult questions. Let me just save it quickly before I lose all my data. Okay, a sphere with a radius x has a volume of 1000 cubic centimeters. Calculate the value of x, and they give us the formula. So I honestly don't know why this is a hard one and the previous one was medium, because in my opinion this previous one was slightly harder than this one. So we have 1000 equals 4 over 3 multiplied by pi x cubed. We want to get rid of this 4/3. So another way of looking at this is just this whole thing is just a number, right? And we're multiplying it by x cubed. So we're gonna do the the opposite of multiplying is dividing, and we're gonna divide this by this, so that this will cancel on this side, and on this we're going to get a weird number. So we end up with x cubed is equal to 1000 divided by 4 over 3 times pi. We can just put this in the calculator. Let's do it. Divided by, open brackets, 4 times pi divided by 3, close brackets. 238.7324. And let's take the cube root. So remember, the opposite of cubing something is taking the cubed root. So we end up with x is equal to the cubed root of 238.7324, and that's equal to, the calculator will tell us. On my calculator, cubed root looks like, oh, I cannot find it. How will I do it? Cubed root, I hope you have a cubed root on your calculator, but in my case I'm going to use this x to the power of y, but instead of using 3 I do -3. So x to the power of -y is equal to the y-up root of x. This is something we have to learn in the algebra chapter. So we'll do this to the power of -3. Let me just put these brackets just in case. Just when in doubt, use brackets. Oh, that seems like wrong. Oh, I'm stupid. I made a big mistake. You see, this, even though I made a big mistake, it illustrates a good point. Always sense check. Do a common sense check. This answer I just got does not make common sense, because I forgot a simple thing, which is that x to the power of 1 over 3 is equal to the cubed root of x. Or to be more precise, to be more general, I mean, 1 over y equals the y-up root of x. Let me just this we learn in algebra. So even though I'm a bit embarrassed for making such a mistake, it's actually good because it illustrates the importance of sense checking. One divided by 3 is equal to 6.2035. And now we can just check ourselves to make sure that's right by doing it in reverse and seeing if we get the same thing. 230. That is correct. So the answer we're looking for is 6. This. What was it? Centimeters. In fact, let's check it entirely. Let's fill in x over there. 6.2 cubed equals that, multiplied by pi, multiplied by 4 divided by 3. So I'm just taking this 6.2 and filling it in over here. And if I didn't make a mistake, it should be almost exactly 1000. Just a small difference because of rounding error. Let's see. The moment of truth is here. Yeah, it's almost exactly 1000, which means I double check myself, which I'm pretty sure I got all 3 points for this one. Okay, next, question 11. The diagram shows the front face of a barn. The width of the barn is 12. The height of the barn is 8. And the sides of the barn are 5. Work out the area of the front face of the barn. So it might be tempting to say width times height. That's easy. No, this is a shape that consists of two shapes. It's a shape that consists of a rectangle and a triangle. The A1 and A2. A equals A1 plus A2. A1 is easy, right? It's 5 times 12. And A2 is this triangle shape. And if you remember, A2 is half, oh, excuse me, undo, half of the height, which is, in this case, 8 all the way to the top, minus 5. So that's equal to 3 meters. So the height of the triangle, not the height of the whole barn. Half times 3 times base equals let's go to the calculator. 5 times 12 plus 0.5 times 3 times 12. 78. Meters squared. And then the next is asking about the volume of the barn. So remember, this is a prism. And I said the area, no matter how weird an area it is, remember, the volume, so long as the cross section stays exactly the same throughout, the volume will be A multiplied by the length. So in this case we had A is 78 multiplied by the length is 15. So the volume is 1170. We only get 1 point for that, which actually kind of gave us a clue. The fact that we only get 1 point from this shows that it's actually very easy. So that might help us realize that we probably just need to multiply. Okay, moving on with the last question. We have the length and the width of a rectangle. And we have this diagonal and we have this sector of a circle. And we want to know the percentage of the rectangle, which is gray. 5 points. If you don't know how to get this area, you might still get a point just by saying P for percentage equals area sector. Oh, excuse me, let's cross that out. Area rectangle minus area sector divided by area rectangle multiplied by 100. That's the percentage of this gray area. It's the whole area minus this, that leaves the gray area, divided by the whole area, and then multiplied by 100. So A rect is easy, right? So we might even get a point for A rect. Rect equals 4 times 11. So even if you don't know how to do it, you may as well write this part, and you might even get partial credit for it. There's no point in leaving it blank. And I don't think that what I did so far was really too hard for anybody. You should be able to recognize this. But now comes the tricky part. We got this area of this sector. And remember, I told you, let's say this is theta. Let's say this angle is theta. The area of a circle, the area of a sector is simply theta divided by 360 multiplied by the area of a circle. And we can get the area of a circle, right? Because we know the radius, which is 4 centimeters. So all we need to get this white area is this. And this is what we need trigonometry for. And I actually didn't teach you trigonometry yet, but this is what we're coming up with next. So that's why, for those of you who are in my class, I actually removed this from the paper. So I don't count this. But I gave you an option. If you did a good job trying to solve it, I gave you 1 bonus point. Anyway, let's figure out, let me just tell you how to get this angle. Remember that tan of theta is equal to opposite over adjacent 11 divided by 4. That means that inverse tan angle is equal to we're going to cover this in class if this is confusing you. Let's just put a little implies that sign, which also implies that the angle equals, let's do it. How can I do, make sure your calculator is on degrees, very important. How can I do the inverse tan on this calculator? Here's a tan button. I think I can do it like this. Okay, let me just clean this up. Tangent inverse of, let's check 45 degrees, see if we get a sensible answer. No. Tangent inverse of 11 divided by 4. Is 70 degrees. Does that make sense? Yeah, it makes about rough sense. It's less than 90 degrees, but it's quite a wide angle, which makes sense if you have a long base and a short height. So, on your calculator, you probably have an inverse tan function, or if you don't see an inverse tan function, like a tan minus 1 function, you might see an a tan. Just look for where it says a tan, and that counts as the inverse tan function. Okay, now that we know the angle, we can fill this out. We can get the area of the sector. So we have 70 point something divided by 360 multiplied by the area of a circle multiplied by pi multiplied by the radius, which is 4 multiplied by 4. So we end up with this equals 9.7762. Why not? And now that we have the area of a sector, let's just clarify that we filled it in like that. And then we're going to fill that in over there. We get 4 times 11, 44 minus a sector, 9.7762 divided by the area of the rect is 44 multiplied by 100. Let's see. 44 minus that, enter, divided by 44 multiplied by 100, 77.78%. Does that make approximate sense? Does this gray area seem like it could be 77.78% of the whole rectangle? I think so. So I'm going to leave it at this. And that brings us to the end of the paper. Thanks a lot for watching and see you in the next one. Bye for now.